Hello. Hi, good morning, good afternoon, wherever you may be. Thank you for joining this session again. If you join us for the first time, where have you been? But if you're joining us for the second time, then welcome back. Today, we're going to go through the actual the color in production session. What we did last week, is that we were walking through, I feel like, the basics of color. So this is the second one of three of a series, if you like, of the series. So we're trying to actually sort of walk you through the actual sort of fundamentals of color, the basics of color. Then we go to color in production, if you like, then the verification. But if you missed the first one, you can see a link on your screen now where you can actually sort of download and actually catch that one. You may have also gone through and actually registered for the first one or the third one already. Anyway, so that's you can still catch it, is what I'm trying to say. The link doesn't expire, so it's you're fine to catch up whenever you wish. But today we're going to go through the actual color and production. So Mark and I are going to do that. So Mark, over to you.
Thank you very much. All right, so let's go ahead and jump in. So what we're going to work on today is a little bit about managing expectations for you and your customers. Working with standards, both spot color and process color standards, different kinds of print processes and how they play out with this, and some process control. So one of our big challenges now is dealing with the fact that we're having our packages printed by a wide range of different printers on different substrates across different plants. And we're expecting some predictability, some consistency across these. So we have to have ways to communicate color and manage color so that when all these colors hit the shelf, we get expected results. We get similar color across all the different types of packaging products as they hit the shelves. So, color is a critical component of packaging, and the use of color is intended to influence the buyer of the product. And for some of the products, incorrect color could imply that the product is not fresh or perhaps is even counterfeit. So consumers are going to consciously or subconsciously choose an alternative product based on unexpected color differences. So print buyer color approvals can include shipping of samples back and forth, or even travel for press approvals. And with brands looking at their environmental impact and the need to increase sustainability, all aspects of the production must be scrutinized for waste. Color issues are responsible for up to 60% of rejected packaging product. That increases the cost for the brand and the supplier, and the waste of that material then must be sent off to a landfill, and then resources are used to replace that packaging. So we want to make sure that we're managing this thing, this whole process throughout this whole supply chain. And so we start out with, at the beginning of a project, we're going to specify the desired colors. And in some cases, these colors are not communicated very well throughout the supply chain. In other cases, the desired color is simply not achievable with the inks or the substrates, but yet the unachievable color is specified anyway. So with each step, there's a chance that the ambiguous color descriptions or the production limitations are going to lead to a shift in color and disappointment. So if we plan better for achievable color specifications and unambiguous color communication, the results are going to be more predictable, more repeatable. So let's look at this process and how we can kind of control this so that we get that color all the way through, specified correctly from the beginning, and hit those numbers in the end. So with spot colors. So again, setting expectations. What you're seeing on the screen right now is representation of different gamuts that we can work with. And you're going to experience different results of reproducing spot colors in different ways. So here we can see where we compare these different gamuts or color ranges compared to spot colors. So The largest gamut framed out there is that of a high quality graphics display. In this case, it's actually being able to achieve the full range of what's called Adobe RGB. All the dots that you see scattered across that area represent all of the Pantone colors in the Pantone library. And so you can see actually the Adobe RGB exceeds most of the range of those Pantone colors, but there's a few. If you look up towards the top, you can see some of those yellows and oranges that stick out there. And if we looked at this in a 3D model, you'd actually see other colors are sticking out elsewhere beyond that range of that Adobe RGB. Now, imagine though you're viewing on a lesser quality display, like say a laptop display or an inexpensive, not a high quality graphics display, but say one of these inexpensive ones. That range is not going to achieve all of Adobe RGB. It's going to be significantly smaller. And it's kind of anyone's guess as to which of those Pantone colors would fall in gamut or outside of gamut of that display. So you could be viewing colors on that display that aren't accurate or not even achievable. Now, these Pantone colors, they're based on a formulated ink. They're made outside the press room. They're mixed with different pigments to achieve those colors. And those colors are beyond that that we can achieve in your traditional CMYK inks. Now, in some cases, for production limitations or costs, we will try to convert those to CMYK. Well, that's the smaller gamut you see in the middle of the screen there. So you can see there's a lot of colors that just won't convert acceptably into that CMYK range. So if you're going to go to CMYK, you need to expect that there's going to be a smaller range of colors you can achieve there. Some are going to be perfectly fine, but some of the more vivid, saturated colors are just going to be unachievable. So this, what I'm showing in this slide here is that some of those Pantone colors, as I said, can be reproduced in CMYK, but others can't. Okay, the Pantone Bridge Guide actually can show you how well some colors can be reproduced in CMYK on an offset litho press, just as an example, on a bright commercial stock. And you can see in this example, the color page that I selected here, the second row across there is the spot inks, and the top row is the CMYK near equivalence, and they're not very close, as you can see. So it's not really achievable there. So that using this guide can help you make some decisions early on in the design process. Do I need to run this as a spot color, or can I get away with building this as a CMYK? Keeping in mind, this is on a process that has a fairly large gamut for CMYK on a bright white stock. If I can't get it there, I'm probably not going to get it on many of my other packaging materials in CMYK. Now, down below, the bottom row there, that's actually a guide that has been discontinued. Pantone produced an extended gamut guide using CMYK, orange, green, and violet in the past. And although it has been discontinued, it's still a really good example to show here that those colors produced with the additional inks of orange, green, and violet expand that gamut enough that the reproduction quality, the good color that we can achieve on that extended gamut is quite acceptable compared to the spot inks that are in the middle row there. So, you know, picking the type of process you're going to go to early on is very important here. And these kinds of tools, the Bridge Guide in particular, which is still available, is a very good tool to make those decisions early on in your process. With Esko, they have a feature in their Equinox, which can digitally provide the proper conversions to the CMYK OGV, or orange, green, violet, for your particular press condition. So you don't need a physical guide like this that has been discontinued, because you've got tools like Equinox to do the conversions to your specific print condition. And we'll talk a bit more about that later. So physical guides, we've had them for years. We use them a lot, but they do have their limitations, okay? The Fandex and many others types of printed pieces, well, they're printed oftentimes on a printing press, and we know from experience, printing presses do have some variability. So even though, say, like the Pantone fan deck is printed with very tight tolerances, there's no two Pantone books that are identical because of the variation on the press. And then the ink room proofs, well, they can vary from proof to proof, and they may not even be totally uniform across the proof. When you've got these, they're not used as much anymore, but I still see them out there, the light standard dark guides. Those can lead into problems where some people interpret that as you've got your choice of 3 different standards. And maybe I like the darker one. That's not how they're intended. The light standard dark is intended to show what are we shooting for. That's the standard. And the light and dark are simply showing the ends of acceptable range. But oftentimes you'll see people that'll pick the lighter or the darker one as something to run to. That's a problem, okay? And with all of these physical printed pieces, they're all subject to age and use. So as they age, the paper is going to yellow and the ink is going to fade. They're going to get soiled with use, fingerprints, smudges, and such. Okay, so they're going to change just by using them, and even just letting them age. Though they will change. These are intended as visual guides, not as standards. In fact, when we just look at an ink proof scenario, if an ink proof is required for a customer approval of a color, there's a lot of waste there, because I may have to make several of these proofs and ship them back and forth, and to get approvals on these things. Okay, and then perhaps I get into a situation where my print buyer says, "Hey, I like this, and I want you to make a bunch of these proofs, and we're going to send them out to all the locations that are going to print our work." And there's going to be some variation between them, and then that's going to add to what we call the error stack. And there's a lot of other pieces that can add to it. Okay, so the error stack is the result of adding all the sources of error in our process. So when we're working with those physical visual standards, there's user subjectivity and, of course, the differences, and those are going to add up in our error stack. So when each of the vendors receives a slightly different version, and then they measure it in their ink room, and they make their ink, things are going to go out of control a little further. And then the press operator, if they're given one of these variable ink standards, or even worse, the local ink room makes their new ink standard based on their measurement and hands that to the press operator, it's going to add even more variability to their process. Okay, and then take that out to multiple plant locations or multiple suppliers, right? And then what happens is the store shelf, we've got even more variability. Okay, we've got products that aren't the right color. Okay, they don't match up, they don't look like they belong to the same family, these kinds of issues, and the print buyer's not happy. So this is a real world example where we went out and looked at 3 different printers, and they were tasked with hitting the same physical standards. Okay, each of the ink vendors did their best job to hit the color, and each ended up in a little different direction from the original. Okay, and they established their own press standards, and based on their achievable matches in their ink room. Okay, and although they stayed tight to their standards internally, as you can see here, those dots there for converters A, B, and C, they're nice, tight clustered, so they maintain good consistency. When you compared across suppliers, we ended up with about 3 delta E in the packaging. Okay, again, not desirable on the store shelf when we see that big a difference in color. The difference with digital standards is they're precise, they're repeatable, they're scientific. Okay, they're distributed oftentimes in a file format called that's a color exchange format, or also known as a CXF file. They need to include more than just the LAB of the target. They should include the spectral data as well. As we spoke in our previous session, a lot about why spectral data is so critical. It's used for getting good matches, much better matches for our inks as they get formulated, so that they remain consistent under different viewing conditions and such. With the digital standards, if you're handing off CXF files, there is still some risk if they're not controlled. So you want to make sure that you're working with the true standards, not something that maybe was measured or remeasured by some unknown or unqualified source. Once the digital standard is produced and approved, that data is the one truth for that color. Some common ways that users end up with invalid digital standards are when a supplier decides to, say, measure something that they produced and make that their standard, or measure some other book or some other physical standard and then use that in place. And they may save it as the same name. They may put it in their database and then export that out as a CXF. In that case, it doesn't match the original, so your production's not going to match either. So you do have to be careful about controlling the source of where do these colors come from. Okay, make sure if you're distributing CXFs that you're always using the one that was provided from the original source. So it does take some management there. So we print brand colors on a wide variety of conditions, substrates. So how do we manage these for consistent and predictable results? So Pantone, well, it's widely used. A lot of brands like to use it because they can use their printed fan decks to visualize their colors when they're making their designs, coming up with their ideas on these things. And the books are similar enough that viewers at different locations can pull out their books and view and discuss the colors from anywhere. Okay, so it's a really good tool for like remote discussions of colors. So we don't have to be in the same room. I can grab my book, you can grab yours. And if we call out a color, we can look at those and say, hey, does that look like what we want to use in this design, right? And then every printer and every ink supplier can understand what's requested when they are asked to produce a particular Pantone color number. Pantone is a cloud-based system. The digital values are stored in libraries, and they can be accessed by a variety of software tools used in every stage of the process to assure that we have constant communication of color across the supply chain. The printed fan decks represent the specified ink colors as they can be reproduced on a high-quality, bright white stock. Happens to be offset press. But these colors can be reproduced in many offset print conditions, especially those running on a bright white stock. And if you're running offset, flexo, gravure, or any similar on any kind of similar bright white material, and if the inks you're using are capable of vibrant color, a good match can be achieved. Okay. However, things get a little bumpy if the desired color cannot be reproduced on some other substrates. If your product is on a white film or a clear film with a white backer, or say a folding carton board or any number of other materials in different kinds of press conditions, or like this brown craft, things can be a bit different, okay? Some of the inks used are going to have requirements for rub resistance, for food safety, for fade resistance. And some of these inks may not be able to reproduce the wide range of colors that we had in our Pantone books, okay? So how do we deal with this? So in this example here, I might be able to reproduce the Pantone Master on my customer's bright white cup. But what about that brown craft sleeve that we have here? Well, there's no way I'm going to hit that, okay? So if I'm producing this sleeve at 5 different suppliers or 5 different locations, and I only provide the original Pantone color that I used on that white cup, right? Well, they're going to go to their ink guys, and their different ink vendors are going to do the best they can to match those that color in their ink room on that substrate. And there's going to be some approvals going on, but in the end, I'm going to end up with very likely 5 different results. They all did their best to match the best they could, the lowest delta E, but they end up with different directions, okay? Which one's correct? Which one should I run with? Well, I can accept the reality that this brown craft is not going to allow me to get a match. I need to get a match across all my different suppliers to show up on the store shelf looking the same. I will end up with very different results if I just give them the target that nobody can hit. If I provide a linked dependent target value that is achievable for that specific print condition, then I've got a much better chance of hitting this. So Pantone Live is an example of linked standards that are proven achievable under different print conditions. This way, every ink supplier is going to target the same linked dependent standard for my master color every time. They're not going to match the original master, but they will all hit the same linked version of that, the dependent standard for that. And Pantone Live dependent standards have been developed for all the Pantone master colors on currently up to 42 different print conditions and growing. We're doing more and more. And these are all stored on a cloud server as a subscription service for various software tools used in your supply chain.
Mark?
Yes.
Yeah, just a question for you, if you don't mind. I mean, is there sometimes, aside of Pantone Live data there, do you actually have, is there any way of actually exploring or investigating a CXF file to know where that CXF has actually come from, where the source of that CXF is? Is it in the metadata of the CXF at all?
So in some cases it might be, but oftentimes it's not. But yeah, if you open up a CXF file in a text editor, you sometimes will see in the header or some descriptions in there saying the type of instrument that you use to measure it, and perhaps the software that wrote the file. Some things like that may be in the metadata, but oftentimes it's not, and that's still no guarantee that you actually have the valid original source. You do have to be very careful with that. Whereas with the Pantone Live and some other libraries, for example, Esko hosts Pantone data in their system, in their books. When you get it from those sources, it's coming from that one truth, that one original source, and they're kept up to date as well. So when Pantone adds new colors, those are immediately available in the Pantone Live libraries.
Okay, and in terms of actually creating an actual digital standard, are you going to touch on that next, or have you got advice on those things?
I didn't plan on touching it, but I can add a little bit about that. So, when you're using software like ColorCert or IQC or any number of other QC applications, there are options to export out a CXF. And oftentimes they'll offer you options of what to put into that data. So you could put in just LAB, or you could choose to add the spectral data. If you're creating a new standard you want to share with others, especially the ink formulation people, make sure that you add in the spectral data in that CXF file.
Thank you.
Mm-hmm. Excellent questions. All right. So to recap a little bit about the digital standards, well, they're unambiguous and unchanging if managed properly, taking into account all the stuff we just spoke about, right? The CXF can be used to distribute the color digital standards, but be careful of the source. Make sure you're tracking them, and you've got, you're distributing the one good color to your. If you're a specifier and you create this color and you keep this, archived and you share it with people, make sure you're always sharing from that same one color, not recreating it. And those of you who are the print suppliers, make sure you're always working with the provided CXF and not creating new versions of that. Don't take a CXF, have your ink guy make a new drawdown, then remeasure that drawdown to use that in production. That's a new standard. That's not the same thing. Okay. And again, with the Pantone libraries, these are distributed through the cloud server directly to applications. Okay, so that you connect your applications directly to Pantone Live to get that. They include the coded and uncoded, as well as the pastels, neon libraries for coded and uncoded. And Pantone Live is going to provide you with currently 42 different standard libraries to reduce the error stack even more by providing known achievable targets for the ink room and the press room. So at this point, I'd like to hand it off to Martin to discuss the pre-press part of this.
Yeah, thanks, Mark. Just the next slide, please. So early in the slide deck, Mark is actually referring to about the actual how to actually best manage the actual color in the process. And if you like, the slide was actually titled, "Where does color go wrong?" And as illustrated in the actual slide, it was trying to show you that as the color from origination, if you like, travel through the production process and out and back again to the actual originator, if you don't communicate these colors properly, or if you don't handle the color communication properly, you have a chance or an opportunity of moving or changing that color as originated from. So again, what we're trying to actually give you here is, if you like, best advice of how to do that. And as we move towards now, if you like, into the pre-press section, there are certain ways as well that you could actually have certain implications of doing that. So I'm trying to show you here is a case of you'll have maybe, if you're staying within the Adobe software, when you install the Adobe software straight off the actual, off the bat, if you like, the original color settings that it comes with may not necessarily be to your desired specification. Meaning a case of that your organization may work to a given specification, and Mark is actually going to touch on the ISO specifications and so on, standards in the next slides, but it may come with, or it will come with, like a US swap coated by default, usually. So if somebody else then goes into that maybe workstation and starts to edit some of those settings, they could actually be editing unnecessary. So the top half of this actual slide is trying to show you that maybe a CMYK file comes in untagged. Your color settings may have actually set to be saying, or I'm going to, let's say, discard profiles. And therefore, you then, when you try to export it out as a PDF, or you're trying to share thereafter, you may not actually then include any information when passing that file on. Whereas the bottom, you could turn around and actually say, hey, I do understand this process. I do want to respect the profile that's either been given to me, or I'm going to assign a profile to it. So as it enters, this file enters my building, we work to this given space, whichever that may be. This is what I'm going to respect. This is what I'm going to use. And then again, as it travels through your organization and back out of your building, you can again start to manage it accordingly and then share it out again accordingly. So it's very important to actually to respect these settings. So in the next slide, Mark, we can actually then start to actually look at what those settings could look like. So here is a typical example where you can actually go through and you can actually then start to choose the preferred settings that you actually want to work in. And then so in the working space, you may turn around and say, well, we work to, from an RGB perspective, we work to sRGB. That's what we prefer to work to, for various reasons. And again, CMYK, we actually work on the ISO coated. So this is the CMYK workspace that we actually want to work with. Now, again, geographically, this may change. You may turn around and say in the US, you want to work to a different standard. And this is why I'm trying to flag it to you that you best respect whatever that may be. So you don't have this mismatch as it jumps from maybe workstation to workstation. You don't, if you can be quite smart about this as well, and you can turn around and actually then start to say, okay, this is what I want to work with. I can actually then start to say, do I want to look at when a profile mismatch is actually occurring? Do I want to prompt the user to be able to do something with this or not? What would I prefer to do? So again, you can set those up. And you can again turn around and actually say that you want to save these settings. If you save these settings, then again, they could be readily available for your colleagues to actually then go and pick up on their workstation. So you can again make this a lot simpler for you. The next slide, please, Mark.
Actually, I'd like to add one little thing about the saving settings as well. Is you set these in one of your Adobe applications, and you can save it. And then if you look at the top of the screen, it shows that this particular setting is unsynchronized. if you go to the bridge and you load that settings into the bridge and apply it to all your apps, then all of them will be synchronized. So as you move from, say, Photoshop to Illustrator, or if you're even doing some stuff in InDesign or and all the Adobe apps, you can synchronize them to all behave the same way in one location at the bridge.
Again, here, as I said, that's when you go to share that, save that Adobe PDF with the PDF, what do you actually want to do with it? So do you actually want to include all the profiles with that? So again, in doing so, as I said earlier, when it leaves your building or when you're going to share it with your colleague or your customer, you're giving it the right information that you actually want them to use. And I'm just touching on here the Adobe applications, but I mean, if you're within the Esko family, then the color settings or the color libraries that we actually use from within Color Pilot, again, can actually be then shared within the rest of the applications. So the likes of ArtPro Plus, everything else can actually then pick up that information and actually then start to use that accordingly. So we're just trying to indicate to you here about, like I said, the best practice is setting it up once, adhering to a set specification that suits your organization, whichever that may be, and then you can save it accordingly. Next slide, please. So as I said, is a case of that we're trying to indicate here to actually say that Mark's already touched on the unsynchronized option at the top, and you can actually then turn around and actually say that what do you actually want to do with this? Do you actually want to share it? Do you actually want to do anything with it? Anytime you actually go and change some of those settings, you'll actually see the settings at the top has gone from maybe a name, a default name, to custom. And then you can here and go to Mark's point and hit say save, and now save it with a defined message that you actually want to actually use. And this, like I said earlier, can actually be shared accordingly. Next slide, please, Mark. So we've already touched on the likes of cloud. We've already touched on, let's say, specifically the likes of Pantone Live in the cloud. Well, again, no surprise that Esko also are actually starting to actually centralize a lot of their database in the cloud. So here you can see that whether it be within either a plugin or within the application, as I said, they can actually go and connect to that cloud. The screenshot on the right hand side here is actually showing you again from a plugin, you can actually go and connect to Pantone Live. So here it will actually then start to pull in that necessary data. And this could actually be from, let's say, plugins. If you imagine connecting different software, maybe Web Center to the Adobe software, etc., just to actually make that simplification step easier for you. But not everybody's going to be maybe using the likes of Pantone Live. So they may actually just start off with just generic so-called master Pantone libraries. So everybody's got their own choice that they wish to actually start off with. So they then may try to actually then start to say that they want to use Pantone Connect. So again, Pantone Connect is a subscription model that actually works either on its own or in conjunction with other things. But similarly, as I touched on earlier, is a case of if you are using a question that I got asked quite frequently was a case of what about if I'm just using, where do all my color libraries go if I update my Adobe system and, but I'm using the color libraries from Esko? No, you will not lose anything, because if you're using the color libraries from Esko, then everything carries on as normal. It's not necessarily, if you want to carry on with Pantone Connect, then that's up to you. Next slide, Mark. I think it's back to you.
Oh, no, a little more.
Oh, sorry. So the proof verification, I also want to sort of touch on here, proofing, that we're starting to actually refer to about printing and proofing to specifications. Now, again, here you can actually start to see that we can actually pick up that those default libraries, but also in the workflow, we can also confirm that we actually want to actually measure and verify to that specification that we've defined earlier. So as we produce a proof, the workflow is actually then going to not only just automatically generate that proof, but using the built-in spectrophotometer, it can actually then measure and verify against that specification. And you can actually set the tolerances that you wish. So on the next slide, Mark, I think you'll actually then start to see a sort of window appear that actually then starts to indicate to you what tolerances would you wish to actually use. So again, you can actually specify those sorts of specifications. So again, from a continuity perspective, as we've gone through pre-press, we can set up our color settings in Adobe. If we're actually using the Esko process, Esko again is actually picking up the default color libraries and adhering to those specifications that you've actually going to set up in multiple sites. And similarly, when we come out to proofing, we can also then turn around and say, when we produce this proof, the proof is also measuring to that specification that we've set our organization to. Okay. Next slide, Mark. You may then turn around and actually say that, okay, I don't know where these files maybe have actually coming from. So I actually want to actually go through to actually say that I don't know where the job may be printed. I don't know if it's going to be printed in process for digital. Is it going to be printed on a extended gamut? So we can also go through and actually run a pre-flight of a color pre-flight of that and look at inspect the file that we've been given and actually then determine to actually see how is it best to actually produce this file. On which process is it best to produce this? Can I get produce these files? Maybe if I'm doing it digital with maybe as like an EPM mode, if I'm on an HP press, can I print it in ECG? So we also know from, and we'll talk about this in the last session, we talk about like skill sets dropping as well in the business. So what we're trying to actually do here is actually bring to attention the best informed users to actually say, this is how you can potentially print this job. Here is a report on that. If we want to also generate some information and feed that back into our business, we can create an XML file on that as well. So again, we're not just about actually just looking at the file. Of course, you can look at the file in the editor software of your choice and inspect it, have the same sort of functionality within ArtPro Plus to review how will that, if I open up this get set file and I apply a tolerance of maybe a delta of 2 using this particular color strategy, how will this job be printed? Can I get away with printing it in 4 colors, 5 colors, 3 colors? And it will show you that. Or, as shown here, you can actually just do it in an automated way. Next slide, please, Mark.
Okay. So let's move on and let's talk about how we're going to use spot color standards in production here. So we talked about the digital standards be, saved out, shared as a CXF, or you can pull down from Pantone Live, and so on. You share these with your ink vendor, and they're going to formulate to match the color based on the actual ink pigments and substrates that are going to be run. There is no master recipe for ink to be used in every scenario. In fact, the Pantone formula guides will have an example formula in there that is not intended to be used in production. That's not intended to be used, especially if you're printing in a non-offset environment. Those pigments are based on a specific ink system on a specific press condition. So the spectral data is critical so that my ink formulation software can look at the ink pigments that I have available for my production and build out the spectral curve match as close as possible to that master curve match. Okay, so that's really critical. And then the other piece is that we continually QC those batches of ink. So we're going to measure those batches, and we're going to confirm that they're within the tolerance of what we need to send out to our press room. And we're going to look to make sure that the spectral curves are similar and so on. So you can take that CXF data, or you can connect to your Pantone cloud accounts to pull in the data to formulate and QC in the ink room. Now, let's look at the press room. So we spoke about those color settings in the design apps and the color manage pre-flight. Let's look at how that plays out in the press room. So in these examples, the densities, well, they're the same, but the appearances don't match. Well, how can that be? Well, when the ink colors and the TVI drift out of tolerance, the density is not going to tell you if it's looking wrong, okay? So we can hit these densities all day long and think we're hitting right on the numbers here, but in fact, these look very different. Taking a look at just these two, the LAB values of the inks are very different. So measuring density alone could lead into rejected product that ends up in the landfill and increases the amount of waste and slows down production, and it's going to make customers unhappy. Let's just take a look at one of the colors in this process. We're going to look at yellow. And we got these as real results, measuring on the same substrate, measuring the density, including the substrate in that process. I want you to look at these and think about what you're looking at here. So the first patch, very close to the density target listed at the top. We're shooting for a density of 105 and we hit 106. I'd say that's good all day, right? Well, here's another example, also hitting 106. And, you'd expect it looks pretty similar, but it's not exactly a visual match. Then here's a third that measured a 0.97. And, well, is that lighter? Is that close? So if we look at the color of these as opposed to the density, we see the first patch on the left is 0.89 delta E. Well, that's very good. The one in the middle is 3.27, not so good. And the one on the far right is 6.35 delta E away. That's a problem. And in fact, if we look at these even closer, we can see there's a distinct difference in these colors. And the one on the right is measuring, or color-wise, it is darker looking, okay, but density-wise, it was lighter. And this is because of the way density is measured with a specific filter for each primary ink. So the density for the yellow is actually lighter, but it doesn't consider the contamination or the fact that there's other colorants in this ink, okay? So if we tried to control that press based on the density value from the patch on the right, we would have increased the density of the yellow. If we would have used the density of the middle patch, we'd be running all day saying, hey, we're really close. We're nearly right on the numbers there, but in fact, we're significantly far off, okay? So density is not going to work for us here. Just to reiterate, the far left patch actually is a clean yellow ink, and the other two patches are contaminated by other colors, okay? Now, TVI, I run into a lot of facilities, they're not measuring their dot gains or TVI. These are pretty critical, especially when reproducing images, because the images are all built out of tints. That's everything in here is tints. There's very little, if any, solids in your image area. The image on the left is what we're shooting for. On the right, the top one has the correct solid ink densities, but the TVI, the dot gain, is high. And the one below is also hitting the same solid ink densities, but the TVI is low. And you can see there's a very big change between the appearance of those because we're not monitoring and controlling our dot gain. So to start with, we want to make sure that we've got proper press calibration and a good fingerprint. So the press calibration we're going to do a plate calibration that optimizes the tint curves for that press condition. Now, many of the calibration tools are going to include test charts that have tint ramps, and you can see those in this target. This is a G7 P2P target, and it also includes a number of gray balance builds that can be used with software to help modify those curves to try to give good gray balance between the CMY. You'll run those calibrations to get the plates in line, to get them providing the proper tone values throughout the tint range. Once you've achieved that, once you've got that plate calibrated on that press, then you're going to run profiling targets to capture the fingerprint behavior of that press. And this is going to provide the press run targets during production. So it's going to provide the CMYK solids as well as the overprints. And it's going to provide a full set of data for proof simulation, as Martin said earlier, that we would put in place to try to simulate that process on our inkjet printers. So how do the ISO standards come into play with my press production? Well, there's several ISO standards for print. They're all related to press room, inks, print viewing, and there's several others around color data exchange and PDF. But what I'm going to focus on is ISO 12647 and 15339, which relate to the press room color targets. So as was also mentioned earlier when Martin was talking about your settings in your Adobe apps, we've got different names of our standards used in different regions. We've got different organizations that develop the local standards and methods that they promote to printers in their geographical regions. They're all rooted in ISO standards, however. So it doesn't matter if I'm in North America going to Grackle or if I'm in Europe targeting some Foger standard, they all are going to tie back to some ISO standards. Traditionally, 12647 has been used for a long time as the source for that. And I'm not expecting you to memorize all the numbers here, but I want you to see that in this example here, I've got 4 different print conditions. I got a premium coated, improved coated, standard coated glossy, standard coated matte, and each of these have target LAB values for the paper and the primary inks as well as the overprints. Those targets are part of the ISO standard, but they also trickle down to Fogra or Grackle or Swap or Japan Color, and variety of regional targets or standards. Okay, the traditionally 12647 has been based on TVI tints. Okay, so your tint ramps would be based on targeting specific TVI curves. That has been around for quite a long time. Let's move on to the next one. Sorry. I'm sorry. Critical thing here too is 12647 also includes standards for many different print conditions. What I have illustrated here is 12647-2, which is offset. But there's also other standards wrapped around flexo and gravure and even screen and other printing conditions. Now, 15339 provides several characterized reference print conditions, they call these, or CRPCs. And they're actually based on many of the target values from 12647 as their root, they're where they start from, okay? If your substrate is more than 3 delta E from the selected CRPC, then the use of software comes into place to calculate what they call substrate corrected color aims. And these are slightly adjusted CMYK values and overprint values that take into account the small changes that the paper would have on those inks. The idea is that you're going to adjust your press to match to the closest set of solid inks and overprint target values that are available, and then you calibrate your press curves under that condition. Okay. When you get a closer match then you're going to get closer matches between different presses. They're all targeting the same CRPC. This gets away from a common scenario in the past where everybody would simply run their press up to the highest densities they could achieve, linearize the plate, and then just run. So we'd have a lot of different print standards. Using this method, you're going to limit this down to 7 different press conditions or characterized reference print conditions, and they're what they call print technology agnostic. These are not standards based on if I'm printing, say, flexo versus offset. It's really designed around what's the range of colors that I can achieve on whatever press this is, whatever technology I'm using, and then select that is my target. So as you can see here, these are this is graphs representing the range of colors that each of these conditions is capable of. And well, they're different size gamuts because each of these different press conditions, based on the substrate or inks I'm working with, are capable, different limits of color. Okay. Then what you do is like as I said, you run your press up to the density of the gamut that most closely fits the maximum densities you can achieve here, and those become your color targets, trying to match as closely to one of those 7 print conditions. Then you calibrate your plates using the G7 method here for the G7 gray balance. In this way, I can use that same CRPC on different presses at different locations. I can use that press condition as a proofing target, and I may not even need a custom profile for my proofing. If something changes, I can recalibrate the plates to bring everything back in, but I don't need to rework the artwork files for that different press condition. So just a high-level description of what G7 is, because some people don't quite have a grasp of how that works. It's actually pretty simple. It starts out with looking at the A and B values of the LAB of the substrate, and then it adjusts the A and B values of the measured CMY grays that you're going to print to try to bring them closer to that. And as this graph illustrates at the bottom, these are the target values that we're going to shoot for across the range. So on the left side, that's the paper AB there. And you see we've got a paper that has something like a +2 and a -5 there on the B, okay? And as we move through, the values move closer and closer to the 0 line there, 0, 0 of AB. If you recall, any LAB that has 0, 0 and the AB would be a neutral. So we're getting more and more neutral. We're taking out the influence of that paper color as we get darker and darker with our CMY builds. So in this example, where the paper value has that 2 and -5 as the AB values, at 50, 40, 40, which is that mid-tone patch, well, that would have AB values of half of what the paper is, or a 1 and -2.5. So it reduces the influence of the paper color by half. And we can see the target values graphed and plotted here. So with your print conditions, if you change any of the variables, you change the substrate, the inks, plates, press, analogs, and a variety of other variables, you're changing how that press is going to reproduce color, okay? This will require that you recalibrate that process. You may have to make new plate curves. In some cases, you may need to re-fingerprint that press. If you're shooting for ISO target values, then you can recalibrate the press and bring it back to those same target values you ran before, and the artwork files are going to work just fine continually. You can continue to run those, whether that's the TVI method or the G7 method. You can always bring that back. If you're running to custom values, and this some cases is unavoidable, you have to run to custom values. But if you are, you may run into a case where if some of these variables must change. Say an ink system is no longer available, or substrate has changed dramatically, and you have to change, it changes the color, and you have to switch to that new substrate. Then you do have to go all the way beginning, new fingerprinting, new profiles to be used to generate the new targets to run to, as well as for proofing. So when you go to custom, instead of using ISO targets, then it does require more work to maintain that as things change. So coming back to this graph that I showed earlier, remember we talked about these different gamuts of different devices, right? And all the dots here represent the Pantone colors that we can print by formulating special inks and take them out and running them on the press, right? And if I run CMYK, I remember I mentioned that you're not going to get all those colors. A lot of them will get cut out. Well, there are some other methods that you can use to try to build in a process method to be able to reproduce more of those colors. And we talked about those earlier as extended gamut. Okay. Printing with CMYK plus orange, green, and violet will provide a larger gamut, so you can hit more of those spot colors. And it also provides other benefits. A really big thing is that's going on more and more now is we're being required to run shorter runs, just-in-time inventories. We don't want to keep a lot of material in inventory. So our print buyers are often requiring us to run more frequent short runs, or combining, you end up having to combine products on the same layouts, especially in like offset scenarios, to try to keep down the cost of your make-readies and such. So by having what we call a fixed palette of CMYK orange, green, violet on the press and not running special Pantone colors with all of our jobs, we can actually leave the same inks on the press, switch out the plates, or run more product on the same plates, and reduce those wash-ups between our productions. And this can bring it down our costs. It's definitely much more sustainable, less waste and chemicals and so on cleanup. And the brands do want to streamline their supply chain process because, again, that whole sustainability awareness, they're all looking for how can we reduce our environmental impacts. And some are also going to be looking at digital printing as another production method. And a lot of digital processes are going to also have the extended gamut available to achieve that large gamut without additional spot inks. Martin, do you have anything else you'd like to add to that?
I think that's a very good summary, Mark. I think as I said, that another reason why this has become very favorable is because that we as consumers want more choice. So whereas gone are the days where maybe we actually want one flavor or we want one size of something, as you see on the screen, there is multiple flavors, multiple sizes of packaging. So that's another reason why there's a drive towards this. But as you articulated, Mark, is a case of that there isn't the people want this on demand now. When we may be actually just shopping ourselves online, we want it tomorrow. We're disappointed if we can't get these things tomorrow. So it's a case of that's what we're actually asking of our suppliers. So again, the likes of Equinox is actually becoming more and more popular, but because it can actually allow, as you said, Mark, the converters to be able to actually, instead of actually having this waste, they can actually then start to save on their ink, save on their substrates, save on their materials, save on their make-readies, etc. But still maintain, because back to what you also said at the beginning, is what's that shelf appeal. So I've got to actually have that color maintaining this. I've got to work within that specification. So it's not just about reducing these things. The extended colors actually helped towards that. But the other thing that's fundamental behind a lot of these is the standards that work, which is what you've already referred to as well, Mark, is about the standards have helped. The consistency is there. Maybe some years gone by, there was maybe fixed palette, extended gamut, call it what you will, didn't work or wasn't as effective because those processes weren't in place. So ink has got better, Analox has got better, CDIs and plate exposure units have got better. So you can get more stability on the press.
Absolutely. And I would like to emphasize a little more about the standards is that so currently the ISO standards are around CMYK process. In extending that to the extended gamut, we're still going to calibrate and manage the CMYK part of this gamut the same way. And when we add the additional colors, the orange, green, violet, red, green, blue, whatever, you will still calibrate those in a linear fashion. And then the data from that calibration and the data from that fingerprint are used by Equinox to be able to do the conversions and optimize those colors to match on whatever substrate and press condition you're working with. But without having that fundamental calibration in place, you can't do all those things. So you do have to make sure you've got the calibration in place and you're set up to measure and maintain those targets throughout the press run. There is work being done to develop some ISO standards around extended gamut, targeting what values we should be using for orange, green, and violet and such. It's not finalized. It's not very far down the road yet. But nonetheless, it's still the same logic that we have here. Manage, pick a target, run to it, and continue to measure back to it and come back to it so you can do those conversions with your pre-press tools and be able to run those repeatedly and predictably on your press condition.
So, Mark, in terms of the actual standards, so the G7 standard, for example, is still working, is still setting parameters around the actual CMYK colors, but maybe it actually has does it have a bias towards maybe a focus of the gray balance as well? Is that the difference between that and other standards?
Yeah, so whether you're targeting a TVI based calibration versus a G7 based calibration, the results are actually quite similar. And in fact, once you've calibrated G7, which just kind of adds a layer of balancing the gray balance, or the grays for the CMY there, it's still within the tolerance of the TVI values. So you could actually still hit both conditions when you go to add that layer of G7 calibration. It's still within the TVI calibration typically, and there's actually some work in ISO coming up with what they're calling universal standards that encompass both of those.
Thank you.
Mm-hmm. All right, so moving on. So again, kind of we're talking about there is like you once you've done all the calibration, you've got the plate curves in place to achieve these standard conditions, right? During production, it's really critical that you go back and measure and confirm that you're actually hitting those, okay? So you want to use instruments. You can load in the CXF files of, say, the Pantone colors or whatever spot colors you need to achieve. You can load those into your instruments. In fact, like the exact you see here, we can load all the Pantone and Pantone libraries right into that exact, so you can spot check those while you're running. Okay, but and then it just is this going to help you eliminate that subjective assessment of viewing the colors. It's going to provide pass-fail tolerances along with actionable feedback like best match, which we're going to show you here in a moment. And this is going to provide ink density or ink strength guidance to achieve that best LAB color match. A better method, though, is to actually work within software, okay? Load all those standards into your software and use that, which is going to provide even a better dashboard and feedback for the operator to use to try to bring the color in. Now, what we're looking at right here is our solid color. And this example is showing magenta. But whether you're looking at your spot colors or your CMYK solids, the software is going to provide, LAB targets, not density targets. It's going to provide you color targets. How do you get to the closest color match to the desired either process color standard or your spot colors? You want guidance that uses density or ink strength to control this. Okay, so the target's still LAB. Density is a control factor, okay, but it's not a standard. The tolerances are established between the buyer and the supplier, and they need to consider the print process at hand. So if I'm printing, say, on a brown corrugated stock, I'm going to have more variability in the stock alone that's going to impact the color of the inks, okay? So I'm going to probably have to build into that a little bit wider tolerance of acceptable color on that. But if I'm printing on a stock that's much more consistent and white, like a good quality white stock or something, then I can have a little bit tighter tolerances around that. But I have to consider what the print process variability is naturally going to be. I can't put in unrealistic tolerances. And if I'm running to a custom fingerprint where I'm expected to come back to the same condition that my press has hit before, I may be expected to get a slighter tolerance on that, versus if I'm running my press to an ISO standard and that ISO standard doesn't represent my exact press, although my press is trying to mimic that standard as close as possible, I may widen the tolerances a little bit around that to allow for the inherent differences between my specific press and the standard. So this what I'm showing you right here on the screen is looking at my solid ink colors. Okay, I've got this best match feature here at the bottom of the screen. Let me dig into that a little further. This provides the operator with actionable feedback to guide them through how to use density or ink strength to make the changes to get the lowest color difference. Okay, so look at the top here. What you see on the left side is what I actually measured. What I see in the center is there's a representation of a visual representation of what I'm trying to get to. And then on the right side is a prediction of a possible match. Okay, it's a mathematical prediction, so it's not always dead on, but it's saying that if I increase my ink strength, then I can reduce my delta E down to a predicted amount of somewhere under 0.7. Okay, whereas on the left side I can see my current level. I'm at a 1.79. Okay. That's also represented in the graph below. You can see there. The curved line represents the delta E across the range of ink strengths or ink densities. So this is showing what delta E I expect to achieve at any given density or ink strength across the bottom. And the software in ours, you can switch back and forth between whether you want to show it as a density or strength. The red line here represents my tolerance on my press. In this case, it's 2. Okay, and so there is a wide range of density or ink strength of this ink that is going to be in tolerance. In fact, looking at this one, an operator, if I'm running a flexo press and I'm looking at this, I see that at my current ink strength, I'm a little bit on the weak side. That's that black dotted line to the left there. But if I increase my ink strength to the point where I get to that green dotted line, I'm going to get the best match, right? Well, in a lot of printing conditions or printing environments with a flexo press, for example, in hot summer days, I might have a lot more solvent flash off or evaporation in my inks. And when that happens, my inks are going to get stronger. So actually looking at this as an operator, I'm not in a terrible place, even though it's close to failing. As I run, if this is going to be a long run especially, my ink is probably going to get stronger. It's probably going to get better as it runs. And that whole range of green there is the range of acceptable ink strength. So I got a long ways to go. I could start out with this and expect that most likely my color is going to get better as I run. If, however, I'm an operator and I saw that my results, instead of being on the left side here, my measured results showed me on the right side, barely passing, okay, I would know that, yeah, I'm passing right now, but as my ink solvents flash off or I get evaporation of water in my inks, it's actually going to get stronger and then go out of tolerance. So providing the operator with the idea of understanding, is this ink going to get better? Is it going to get worse? Am I good enough or am I failing? Providing that information up front helps them to get on color faster and stay there and to make the right decisions. Whereas if they just simply looked at a delta E, that doesn't tell them if it's going to get better or worse. It just tells them how good they're doing at this time. One other thing that's critical here is that curved line that I described that represents the delta E. If that curved line is drawn here in a way that does not go below the red line here, that tells the operator that there's something wrong with this ink, that no adjustment of density or ink strength would give them a good match, in which case they would go back to their ink technician and or they'd do a new wash up on the press and reload the ink because maybe it got contaminated. But they wouldn't spend a lot of time just adjusting the ink strength or density to get it, because the graph represents, and the numbers here would tell them that they're not able to get to a good match with the ink that they currently have on press, saving a lot of time. Now let's look at the tints that we talked about earlier. Tints are so critical because that's your images. The methods we talked about, 12647, the TVI based standards, you need to monitor these tints and make sure they're within tolerance. And when they move out of tolerance, you need to make the adjustments to bring it back into tolerance to be able to reproduce your images and your color builds correctly. And that comes very critical when you're doing that extended gamut, that you are within a certain tolerance there. Otherwise, your color builds of your spot color inks are going to go out, right? They're going to shift. So got to get control of that CMYK before you do the ECG. This is a critical thing. You need to be monitoring your dot gains and controlling those for all those color builds you're going to have there. Now, G7 doesn't specify TVI target values, but in fact, as we mentioned earlier, the actual TVI curves are going to be adjusted a little bit to compensate for that paper color, to try to neutralize the gray builds so that 50-40-40 patch looks neutral, right? So for example, if the paper color has a yellow cast, the calibrated tints might pull down the yellow curve a little bit while pushing up the cyan and or magenta curves up a little bit. So we don't actually have targets or tolerances around TVI under G7, but it's still a good troubleshooting tool. You want to make sure they're not moving wildly out of control. So whether you're doing TVI targets or G7, looking at the tints is still critical. And the tolerances, fairly common tolerances that I've got listed here, is around 50%, a plus or minus 4%. And then when you get off in your highlights and shadow tint areas, it's going to be more like a plus or minus 3. Those are typical. Now for the G7 stuff, as we said, that's kind of a layer above to kind of calibrate out to get that gray balance. We look at some terms that may be new to some of you. A delta L describes the lightness, the difference in lightness. And so we're going to look at the lightness without regards to the color, just how light or dark is this tint patch. And then the delta CH looks at the color of that tint patch without regard to the lightness. So it's just looking at, is it neutral? Does it have a color cast to it? Okay. Now, the common tolerances wrapped around this for the delta L would be a change of 3 or the CH of 3. So as long as we're below 3 on those, we're fairly neutral and we're pretty close to the expected lightness of that tint patch. Alrighty, so that kind of wraps up what we've got for today as far as specifying the colors and monitoring the colors in production. So really, what did we learn here? We learned digital standards are unambiguous and do not change. Physical guides, on the other hand, are variable from the start and they can change over time with use. Linked standards, like Pantone Live Dependent standards, provide repeatable, achievable digital targets that you can use on a variety of different materials. And currently we're up to 42 different libraries. Color management begins in the design apps. Specifying and embedding ICC profiles assure that all the users throughout the supply chain understand the original design intent for that file. And it can also be used in your digital workflows to convert the color to other color spaces, whether you're going like digital or whatnot. The artwork files can be managed for all those different kinds of outputs. And lastly, the press must be calibrated to some standard and run to that same standard, whether it's an ISO standard or a custom standard. It has to be run to it consistently to achieve the shortest make ready for repeatable production and less waste. Martin, did you have anything else you'd like to add at this point?
No, I think that's a lot. I mean, again, apologies for everybody that we've overran the time.
Right.
That we as you can see, there's an awful lot that we're trying to do to actually sort of squeeze into an hour. And as I said, I know that we overran, so apologies for that. But we're trying our best to actually give you the information that we believe for this particular in production section. Again, that you'll see on your screen. So here we'll be able to try to actually put more of maybe a connection to all these sort of things about how we can actually maybe work a bit smarter, save a bit more time. You will get recordings of this as well, by the way. So as I said at the beginning, there will be a link sent out to everybody to actually make these things a lot easier. And if you want to catch up another time, you're welcome to do so. In terms of questions, there was a lot of questions coming in. We'll do our best to actually answer them accordingly. So both and Mark will actually come back to review the questions and then come back to everybody afterwards. So please keep them coming in as well. So again, it will just keep on actually sort of getting these questions coming in, and then we'll do our best to come back to you. So thanks again to you, Mark. Have you got anything else that you'd like to say?
No, thank you very much.
Okay, thanks to everybody for attending, and hopefully we'll see you on the next time.
Bye all.
Take care. Bye-bye.